Hi, good morning. It's Gene from the maverickstar Observatory. Guys, I'm going to be really quick here, but there is an important reason for doing this. Yesterday's video I uploaded, I realised, that the audio was terrible. I've got the lead, which I usually use for the microphone, plugged into the computer, but the other end of the lead wasn't plugged into the mic, so automatically the computer microphone had took over, and that's why we ended up with appalling volume or audio. So there was something very, very important I wanted to just clear up in yesterday's video. I didn't do a very good job of that because of the audio, so I want to try and do that today. So I'm going to go through it quickly, but I'm going to point out the important parts. Right, okay, so as we can see, we're looking at the last 3 solar cycles spanning over 33 years. As you know, each cycle is on average 11 years, and as you can see, there is a depletion towards the present cycle 24. The important point is that most of us are aware of what is now being termed the grand solar minimum. Regardless of that, it is what is behind the grand solar minimum that is more important to everybody, and we're going to get into that right now. Like I say, we'll go as quick as possible, but we want to just clear up something very important, something more important than what a lot of people are talking about with this declining sunspot numbers. It's really what happens when the sunspot numbers decline is more important. So that's all I want to draw out in this video, and we'll just keep it to that because of its importance. Okay, so on this graph that we're looking at, there's a lot of data, starting with the top, and I'll just keep it relevant. We've got the monthly smooth sunspot numbers of solar cycle 22, 23 and 24. I've edited this chart with some red lines horizontally and vertically, and I'm going to go through why I've done that. But all this we're interested in is the top 3. Right, so monthly smoothed sunspot numbers, daily sunspot numbers, and Moscow cosmic rays. Now, if we can just pay attention to the top column, we can see solar cycle 22, 23 and 24, and as we saw on the previous graph that I showed you, we know that the sunspot numbers have been declining over the last 33 years, but what that chart doesn't show us is what's been increasing over that period of time. So as these sunspots have been decreasing, what's been increasing is the levels of cosmic rays during that point in time, and I've done some horizontal lines there that you can see on solar cycle 22 here, 23 and 24. But the thing I want to draw your attention to is things changed dramatically after solar cycle 23. And what has changed is, if you look, the red line is above all the cosmic radiation, but on solar cycle 24 the red line is below. That is because it went above 0. Now, during solar maximums, we're supposed to have a massive inflation of the heliosphere, which stops the inbound cosmic radiation coming into our solar system. And the last solar cycle 24, at its solar maximum, failed to do that. That's the key part of the information that I want to relay to you. This is the information that no mainstream organisation has came out and told you, and it's really difficult to get this space environment overview from 2014, but it doesn't make any difference, because from 2014 onwards we got the critical information we needed, and that was what was going on during the solar maximum of solar cycle 24. And what was taking place was there was an inefficiency of the heliosphere to block out at that point in time cosmic radiation. Now if we go back to 23, we can see that it was blocking out at the solar maximum radiation, and even at solar cycle 22 it was blocking out a hell of a lot more. What I'm saying here, guys, is that we have crossed a new boundary, and this is really, really important, because we know how harmful cosmic rays are, and that even during the last solar cycle, the solar cycle that's just ended 24, or is it, if it has come to an end, it failed to block out the majority of the cosmic radiation like the previous cycles. So this is really, really important news. I really want you to understand this, because from this point on we have entered new territory with regards to the solar protection that inflates our heliosphere, that we benefit from being in the solar system. But more importantly, we have a magnetosphere that is depleting as a repercussion of a pole reversal. So we're getting hit twice with the same problem. Both will allow more cosmic radiation in, and both haven't reached equilibrium yet. And one of them, the pole reversal, will allow more cosmic radiation inbound at the point of reversal, and we could be, as you guys know, 2.5 years away from that. We are facing unprecedented times. I can't emphasize the importance of what I'm trying to show you guys here. And this is what now we're turning our attention to at the observatory, which is to monitor the muons, because we know if we're getting more muons on the surface of this planet, then there is more interactions with cosmic radiation in our atmospheric gases, and as a result of those collisions we get more muons. So if we get an increase in muons, we can work out how much more radiation we're getting as the grand solar minimum continues to deplete and not reach equilibrium, and as our Earth continues to go through its magnetic reversal, and as a result of that the magnetosphere reduces in strength. We are already, and we know this, at around about 20 to 25% reduction of the Earth's protective magnetic field strength, and on top of that we have a weakened heliosphere. Both of these allow cosmic rays in. Both of these will be responsible for more cancers and more cardiac arrests across not just the human species but all biodiversities across all ranges on this planet. Guys, when I said yesterday in the title of the video we'd reached new territory that was uncharted, we really have, and that is the point that I wanted to bring across today, just briefly and clearly, so that you do understand where we are right now with the current situations that we're facing. It's not just a case of taking up our time with COVID-19. We have some vast more important problems that we are going to face as a result of what is taking place in our small solar system right now, and with the effects that are taking place on our planet. That is it, guys. So all you need to take from this video is that from solar cycle 24 we really have noticed an increase in cosmic rays even during solar maximum, where every other solar cycle before this point has managed to push away at least a majority of the cosmic rays inbound into our solar system. That is no longer the case. That's why we face uncharted territory. Guys, the only other thing I want to emphasize here of equal importance is, obviously I understand you guys do enjoy the positive approach that we have here at the observatory, but I just want to say our funding for the observatory is really dwindling away, much worse than what it does over the Christmas period. We can only bring you this data if we're funded. This is a public funded observatory, and it must be funded by the public. So there is a link down there if you want to help support what we do at the observatory. I will say no more other than, guys, you have a great day, look after your loved ones, and as always, bye for now.